Hi everyone. My name is Isaac Maze-Rothstein. I'm with Greentown Labs. I want to introduce Dan Oliver at Voxel8. First, I just want to give a quick overview of Greentown and our manufacturing initiative. First, Greentown, we're a community of entrepreneurs solving the world's largest energy and environmental problems. Our team helps to provide the resources, so the space, other resources and funding that these entrepreneurs need to really grow and thrive. Our story starts in 2011 with 4 entrepreneurs finding each other on Craigslist. 3 of them had just been kicked out of MIT lab space, and they all wanted space to actually build prototypes in Boston, in and around Boston. Over the 4 years, we've grown to the nation's largest clean tech incubator with 40 companies and in a huge range of spaces sort of surrounding clean tech, so transportation, energy generation. And it's important to understand that all these companies, or the vast majority, are building hardware. So our facility is 33,000 square feet. We have a co-working space in the front, but in the back there's a lab space. So the idea is you can have a meeting in the morning, realize you need to change your prototype, go in the back, work on your CNC, come back out with a new product the next day. And that's what we're really focused on doing, is how you make these prototypes and how you sort of move from get to market. So in terms of where startups, the Greentown startups come in, they've often gone through an accelerator, they have a business plan that they've laid out, and they have their prototype, or often their first pilot, and they want to go to market and really expand. And that's what we've been seeing by and large. Our companies are growing dramatically. They're doing a really effective job of raising financing. Voxel8 is a great example of that. And we're just seeing a lot of positive growth. So as we've been working with these hardware companies, one of the questions we've been thinking about is how we connect with manufacturers, especially in the state. Worcester is amazing in terms of sort of the manufacturing resources here. And then how do the startups in Boston, in and around the state, connect to those resources? And that's the sort of problem that we were seeing. We were seeing startups struggling to make that jump from prototype. The engineers were struggling to make the jump from prototype to manufacturable product. And so the thesis that we were exploring is whether Greentown could be a resource to really help these startups make that connection. And we've come to believe, fundamentally, is that if you have a great idea in Massachusetts, you should be able to build it here. What that has turned into is, through the support of Mass Development, a quasi-state organization in partnership with Mass Manufacturing Extension Partnership, we've worked to design a program that really provides educational resources and relationship building for startups and manufacturers. So this includes office hours, workshops, the font got messed up there, it looks like, and really just building connections where appropriate. So we've been at this now about 8 months, and we've been seeing some really exciting results. First, just in terms of just trying to collect data and understand what's out there, we've talked with over 100 startups and manufacturers, worked with folks not just in Greentown, but really across the state in terms of startups. And what it's all leading to is building better relationships sooner with people in state. There's a startup we were working with recently who told us before they had started talking with us that everyone said they had to go to China. And after working with us, they think that they can work entirely in Massachusetts. And that's what it's all about. Just one quick example, this really illustrates the wealth of resources across the state. And so this is sort of important. While our incubator is in Somerville around Boston, we're connecting with manufacturers across the state, and the 40+ companies in our facility will be able to do business with many of them. And that's what's really exciting. I just want to drill down on one quick example. Dynamo Micropower, and you can sort of see the quotation. Hardware company, really had some really exciting traction in their market, oil and gas. But in terms of making the leap and finding the right manufacturers, they needed a little bit of help. So talking with us, we were able to get them connected to a Incubate Mass grant. What that allowed them to do was work with manufacturers at a discounted rate and allowed them to hit their sales numbers up to this point. And so it's about building those relationships so that we can make more stuff here. That's fundamentally what the program is about. If you would like to learn more, please find me afterwards. My email is here. And it's in that context of sort of this incubator, our co-working space, that Voxel8 has really grown and exploded in a lot of ways. So without further ado, Dan Oliver is the business lead for Voxel8. They're a multi-material 3D printing company. Dan will explain more. Thank you.
Well, thanks for having me. I'm going to be talking a little bit more about transitioning 3D printing from creating prototypes to finished products. We already heard a bit about that, but we have kind of a different take based upon some new technology coming out of a lab at Harvard. So the basic idea with Voxel8 is we're bringing new functional materials to 3D printing. So this is the idea that typically people have been limited to either a single material, typically plastic, in their 3D printer. But what could you create if you had high strength, high temperature epoxies to print in, or conductive inks, or inks that would be able to create lithium-ion batteries? And what would you be able to do if you could not only print each one of those separately, but if you could combine them together in a single product or a single part? What types of things could you start doing? At Voxel8, we're experimenting with doing electronics integration by co-printing all these materials together. So this is basically the technology we're using to be able to do this. It's called direct ink writing. It's the deposition of viscous paste. So our materials typically come in typically a syringe barrel. It's kind of a peanut butterish viscosity material. In effect, we use like a pneumatic system to push that material out. If you're looking at the top right-hand corner, what you're actually watching there is a conductive ink being printed from one layer through the air with an air gap up to the top layer. So it gives you a feeling of how strong this material is and how good it is at being 3D printed. It also is very robust and allows you to co-print these things together. So we're able to create not only conductive inks that can create wires and interconnects in your 3D printed parts, but we can create functional 3D antennas or embedded flexible sensors in silicon matrices and eventually directly print lithium-ion batteries. And so here's that video again, as I was talking about. That's a viscous paste being printed out of a 30-micron nozzle, basically spanning two gaps here and self-supporting in air. And so that would allow you to do things like wire bonding and things like that, but also just directly print conductive ink traces throughout your parts. So here's that actually, these are strain gauges printed in a silicon matrix. And so this is actually measuring a resistive change as you're flexing your knuckle. And so you can effectively create like a wearable glove sensor. So actually, I don't have the audio on this video, but they actually were able to play a piano with this as well. And so he's able to do different tones and things like that. But you can see all the different benefits you'd have being able to do multiple materials together and have electronically active materials in what you're 3D printing. And finally, this is a cathode, I think. I always forget if it's the anode or cathode being printed. But effectively, this is effectively a lithium-ion material you would come over and print this kind of, E or 3 shape, and then you'd come back and print the anode interdigitated inside that. This comes out of the research lab that Voxel8's technology spun out of. And effectively, they demonstrated having the power and energy density of typical lithium-ion technology from a 3D printed mini or a micro lithium-ion battery. And to put in perspective, that lithium-ion battery is about 1 millimeter by 1 millimeter by like 400 microns tall. So you can imagine doing an array of these in kind of a novel shape, filling up the space inside your 3D printed part to fully utilize all the space with power storage or energy storage. All right, so this is kind of that kind of is the base of the technology at Voxel8. We're going to talk a little bit more about exactly what we're working on. We actually have a couple of former Voxel8 interns and employees from WI in the audience here. So you can talk to me afterwards, but also Michael Perone. I don't see Steve Kelly, but I know he's back up there too. So these guys also know what they're talking about. There might even be some of these pictures, we'll see. So Voxel8. We're using a multi-material 3D printing technology, which is really cool, but what are we going to do with it? Well, the idea is we saw 2 problems. Conventional electronics are, being asked to go into more mobile applications to be more seamlessly integrated and everything. If anybody's heard of the Internet of Things revolution, it's basically about trying to get electronics and sensors into places they've never been before. Well, conventional electronic manufacturing effectively is pretty ineffective at doing these types of things. You're stuck with that kind of typical green PCB board that we've all seen, and then crazy wiring harnesses running out to all these different sensors. At Voxel8, we also noticed that 3D printing offers this great ability to create novel geometries and effectively create things you couldn't create any other way, but typically had been limited to creating single material objects in plastic. So we decided to apply Voxel8's core technology, this multi-material printing, with electronically active materials to help solve both of those challenges. And you've seen a couple of these images before, but these are some of the types of things we've been able to print. We also stress that while we are really experts in the material side, we understand that 3D printing is a multidisciplinary challenge, and we were able to gather a team around the material side to actually come up with a fully functional product. So when you have a new 3D printer, it's not enough just to offer new materials. You can't just shove them through an existing printer. It's also not enough just to be a hardware expert. I'm a mechanical engineer by training myself, and the industry, I think, has attracted a lot of mechanical engineers because we all think it's the coolest thing on the planet. But effectively, chemists and material science had kind of been left behind. So we're trying to bring those people in, as well as innovating on the software side to make sure that we can control these things and also make sure all the materials work together perfectly. So here's a little video. This is actually our lead software engineer. This is the Voxel8 Developers Kit. This is our first product. It's really meant to sit on the desks of high-end researchers at large companies and universities and help them start experimenting with the possibilities of being able to do this multi-material printing. So as it starts to be able to print in 2 materials, a typical thermoplastic, something like you would be able to see from Stratasys, actually a technology that came off patent from Stratasys called FDM, coupled with a conductive ink nozzle using our direct ink writing type technology. So we'll be able to do plastic devices with embedded electronic parts. And I'll have some demos if you guys want to come up and check them out and hold them and look at them. So that's actually a little USB tab we printed out. That's actually a half-finished quadcopter on the printer. And you'll get better pictures of those as we go through. So here's the Voxel8 Developers Kit. As I said, it'll be able to print in 2 materials. The real breakthrough here, though, is on the material side. So if you've ever dealt with other 3D printed conductive materials, we're effectively orders upon orders of magnitude more conductive. And it's important to note, not only are we more conductive, but this is a material that's specifically engineered to be printed with thermoplastic. You don't have to do any post-processing steps. You don't have to bake it. Literally, the part comes off the printer, and it's conductive. So something we're very proud of. We launched pre-sales of this machine at the Consumer Electronics Show in past January in Las Vegas. We were named one of the top 9 innovations there. And we've been selling them this past year, and now we actually have to deliver, which is a little scary, but we're getting there. So this kind of gets back to that question of, well, where is this eventually going? Well, we really want this adopted as a manufacturing technology. And what you're watching here is kind of a typical problem with electronics manufacturing. You can do multi-layer circuit boards, but you're stuck with this flat form factor. And even more than that, you're stuck with actually putting electronic components on effectively 2 layers, the top and bottom of whatever kind of motherboard you're creating. Now, people are effectively, not only is it getting more and more difficult and more complex and expensive to do this, but you're even running out of real estate on these boards. And this is a problem that Voxel8 would be able to solve. We could effectively embed components on every layer and then take that PCB board and effectively just build it into the wall of whatever device you were trying to create. So this is actually an iPhone motherboard, I'm fairly sure, and you can see there's effectively zero real estate left for putting components on. That's effectively a 10-layer board. With Voxel8's technology, since we're printing with a 3D printer, the idea of layers is really easy for us. Effectively, we can create and put components on every single layer throughout our part, so even a very simple part, and you guys can come check this out. I brought this part with me. You could effectively have over 1,000 layers. And so what you're seeing here is a fairly simple digital circuit. We have an embedded chip that we printed electronic traces of. This is actually a CT scan up here in the top left-hand corner. We embed the components as we're printing, print right off of them, print plastic over the top, and keep going up until we have a fully functioning electronic device that just comes directly off your printer. Important to note too that it's not just about the printer and the software to run the printer and the materials. 3D printers are only as good as the design software and the tools you have to actually create parts for them. At Voxel8, we've actually established a partnership with Autodesk. They're coming up with a new design tool called Project Wire that will allow you to create these multi-material electronic devices. This is actually a really great partnership. It was something we were really scared of when we came out. Effectively, they don't typically have CAD tools for manufacturing processes that don't exist. So there was kind of a chicken and egg problem there. But luckily, Autodesk has a really forward-thinking way of looking at 3D printing and actually embedded a software engineer in our team to create a new design tool that our customers will be able to get for free. So this is actually a picture of it. So this is a quadcopter model. In Project Wire, you would actually upload a 3D model. You can then go over here to their electronic component library, drag and drop electrical components either in or on the model. So you're seeing here, we're dropping it there. These are two LEDs, the headlights for the quadcopter, and you guys will be able to see this. I brought a demo of the quadcopter here. You can place them, move them around. You can actually recess them as well. And then I think the next video, we actually get to draw traces. So we effectively have embedded resistor inside there, and now we're using the trace tool to effectively draw conductive ink traces inside that model up to the LED. So you're effectively creating your three-dimensional part. And important to note, after you do this, this basically goes directly to Voxel8 Slicer, which actually Steve Kelly and Mike both worked on. And we do the tool path planning, so it goes directly to your printer. So we want a really seamless process. So I actually don't think it's, oh, it is here. So effectively at the end of the day, you hit print. These are some print parameters, but basically at the end of the day, you hit print and it goes directly to our slicer and then directly to our printer, and you get a fully functioning device. So you can see here you can put electrical components of arbitrary shapes, embed them in. For this particular quadcopter, we didn't build the whole PCB board. We actually embedded an existing PCB, which is what this 3D model is, this kind of long guitar-shaped model. And you can recess it inside that and create the entire quadcopter. So after you do the design software, the next step is actually printing it out. So this is a time-lapse video of the part, and there's your quadcopter flying off your print bed. And I think that's all I got. Oh, and here's a CT scan of it if you guys don't believe it actually has electronic traces inside. But there you go. So what's next for us? Well, we're going to be continuing to expand what materials we're able to print. And then we're really looking to get feedback from our initial customers to start creating a more targeted industrial platform that attacks specific areas. So the creation of not just quadcopters and kind of interesting prototypes, but the creation of three-dimensional antennas, of hearing aids, different medical devices, and things like that. So love to answer any of your questions at the end, but thanks for having me.